Okay, let's unpack this. Imagine the world of competitive equestrian events. You know, the brace, the power, that incredible bond between horse and rider.
It's quite something to see.
It really is. Now, picture that whole world kind of thrown into disarray by this uh, silent, invisible threat. We're talking about Equid alphaherpesvirus 1, EHV1.
A major issue.
Yeah, a major concern for the entire equine industry. It can bring events to a complete halt, cause devastating neurological disease in horses. That's EHM.
Equine herpes virus, myeloencephalopathy, yes.
And recent outbreaks, especially at big international events, have really made it painfully clear. We desperately need better ways to track this virus.
We really do. The current methods have limitations.
Exactly. The big challenge, as you might guess, is that current surveillance, well, it's often just not enough. Especially when you've got hundreds of horses all gathered together at a big event.
It becomes impractical very quickly.
Totally impractical. So our mission today is to do a deep dive into this really groundbreaking study. It explores a totally new, less invasive way to keep tabs on this elusive virus in shared environments.
And how's that?
Not just looking at direct contact, but checking the very air they breathe.
Airborne detection. What's truly fascinating here is how stubbornly pervasive EHV1 remains, despite, all our best biosecurity efforts.
It just hangs around.
It's like this constant background hum that can suddenly just erupt into a crisis.
Yeah.
So this deep dive aims to give you a shortcut, really, to understanding the potential of this airborne detection method.
And why it matters.
And why it could be such a game changer for the entire equine industry. This specific study, it had two main goals. First, to investigate definitively the presence of EHV1 and also EHV4 in shared airspaces and on environmental surfaces at these international horse shows. And second, to critically evaluate if air sampling could actually work as a practical, continuous surveillance alternative.
Instead of testing every single horse individually.
Exactly. Instead of that really labor-intensive method of individual testing.
And here's why that's so important for you, the listener. Maybe you're a horse enthusiast or just anyone invested in equine welfare. EHV1 isn't just like a runny nose for horses.
No, far from it.
It can lead to serious respiratory infections, heartbreaking abortions in pregnant mares, even neonatal death in foals. But the form that really strikes fear into everyone, owners, vets,
is EHM, equine herpes virus associated myeloencephalopathy.
Yeah, EHM. This condition is basically an ischemic spinal cord issue.
That's right. It affects blood flow to the spinal cord.
Which then impacts the horse's gait, their posture.
Yeah.
And it can even lead to what they call recumbency.
Meaning the horse just can't stand up. It's incredibly distressing to see.
Truly devastating. And in the worst cases, it might mean euthanasia or, permanent loss of performance for these amazing animals.
It's a career-ending, sometimes life-ending situation.
And it spreads horizontally, right? Horse-to-horse, direct contact.
Yes, but also indirectly, through fomites.
Fomites, those are the inanimate objects, like brushes, buckets.
Exactly. Grooming brushes, water buckets, feed tubs, even a rider's clothing or equipment. Things that can carry the virus from one horse to another.
And, critically for our discussion today, it's also known to spread through the air. Airborne transmission.
Which is what this study focuses on.
The fallout from an outbreak is just immense. You've got mandatory quarantines, travel bans, events get canceled.
Huge economic consequences.
Absolutely. Significant emotional and economic tolls on everyone in the equine world. It disrupts everything, training, competing, everything.
It really ripples through the community.
Now, maybe a quick biological note here on herpes viruses generally. They're incredibly, cunning.
They are. Once a horse is infected, these viruses establish lifelong latency. They basically hide out in the host.
So they go dormant, like they're sleeping.
Exactly. Silently tucked away, but always capable of reactivation. That's called recrudescence.
Like a sleeping dragon that can suddenly wake up.
That's a good analogy. When EHV1 reactivates, it starts replicating again, often in the respiratory tract, and then it can shed and spread to other horses.
And what wakes the dragon? What triggers this?
Well, stressors are key. Things like transportation, the stress of mingling with new horses at events, possibly immunosuppression, and likely other factors we're still trying to figure out.
Okay, that makes sense.
And this leads us to a really crucial point. Many EHM outbreaks, the really serious neurological ones, they often happen after horses get back home from events where they've been mixing.
So they pick it up at the event or maybe reactivate it there, and then it shows up later.
Precisely. Take the major 2021 EHV1 outbreak in Valencia, Spain. That was a huge wake-up call. It directly triggered the International Equestrian Federation, the FEI.
The governing body.
Yes. It pushed them to demand better, earlier detection methods during competitions. So the obvious question becomes, how do you continuously monitor hundreds of horses at a big event for their entire stay? Individual sampling is incredibly labor-intensive. It causes discomfort for the horses, stress for the owners, and, ironically, it even carries an increased risk of spreading the virus via fomites.
Because you're handling horse after horse.
Exactly. You're moving between stalls, using equipment.
Mm.
And while there are alternatives, like nasal wipes, they still have significant logistical hurdles for this kind of widespread, continuous surveillance in shared environments.
So we needed something different.
Clearly, a new solution was needed.
So with all those challenges stacked up, how did these researchers actually tackle this? They got pretty creative.
They did.
Instead of just relying on sampling individual horses, which we've just established is, well, problematic.
Statistically difficult, yes.
They broadened their scope. They specifically wanted to see if they could detect the virus right there, just floating in the air that all the horses were sharing.
Like environmental surveillance, but for the air itself.
Exactly. Like asking, can the air tell us what's circulating? And this was a pretty robust study, a cross-sectional field study over 10 months. So they got a good chunk of data.
That's a decent time frame.
Yeah. They sampled at 8 different international equestrian events, 6 in Spain in spring 2024, March and April, and 2 in the U.S., Florida in December 2023, and Kentucky in August 2024.
So different seasons, different continents, good spread.
Right. Gives them a really strong, varied perspective. The sampling focused on those temporary stabling facilities. You know the ones. Big tent-like barns.
Yes, common at large shows.
Holding anywhere from, say, 40 to 200 horses, usually divided into smaller units, maybe 10 stalls around a central aisle. And importantly, these barns mostly relied on natural ventilation.
So the air was genuinely shared among those horses in a unit?
Definitely considered shared airspace. They collected 2 main types of samples, 205 surface samples and 37 air samples. Plus, crucially, control samples taken before any horses moved in.
Baseline controls. Very important.
For the surface samples, they'd wipe a standard area, like 3 by 5 centimeters, between the metal bars of a stall gate. Use a saline-wetted sponge.
Okay.
For the air samples, they used a special device, a Coriolis compact portable air sampler. Ran it at max capacity, 50 liters per minute, for a full 6 hours.
Pulling in a lot of air.
Yeah. They placed these samplers strategically, maybe in an empty stall or the middle of the aisle, about 150 centimeters up, pointed towards the occupied stalls.
To capture what the horses were breathing out.
Exactly. And interestingly, in Spain, they sampled twice a day. Once in the early evening, 4 p.m. to 10 p.m., and then again overnight, 10 p.m. to 4 a.m.
Trying to see if timing mattered.
I guess so. Then all samples went for advanced lab analysis, qPCR and dPCR. Think of them as super-sensitive DNA detectors.
Molecular methods to find and quantify the viral DNA.
Right. And the key baseline finding, all those pre-horse samples, completely negative. No EHV genomes found before the horses arrived.
Which tells us the virus detected later came from the horses themselves.
Precise.
The intention here was clearly to develop a non-invasive tool, something cohort-based for surveillance that could assess groups of horses in these shared environments.
Makes sense.
And it's not an entirely new idea in principle. It draws parallels to how shared airspace sampling has been used effectively for other things, like detecting SARS-CoV-2 in human settings.
Oh, interesting comparison.
By looking at the shared air, the hope was to get a broad, maybe even real-time snapshot of what's circulating among many horses at once, getting around those logistical headaches and the biosecurity risks of constant individual testing.
Okay, so the results, were they eye-opening?
They really were. Challenged some long-held assumptions, I'd say.
How so?
They found EHV1 frequently in the air samples. You mentioned the locations Spain, Florida, Kentucky.
Yeah, 20 out of 28 samples in Spain, all 3 in Florida, and 3 out of 6 in Kentucky. That sounds significant.
It's absolutely significant. That's a remarkably high rate of detection. It points to a pretty widespread presence of the virus's genetic material in the air at these events.
Wow. How did that compare to the surface swabs?
Well, surface detection was lower overall, 15.6% in Spain, 26.3% in Florida, and actually 0% in Kentucky.
0 in Kentucky. That's surprising.
It is. It tells us something important, potentially, about how the virus is moving around, maybe being more readily airborne than sticking to surfaces in some conditions. They also looked for EHV4.
Right, the other common equine herpes virus.
Yes. Found in air samples in Spain, 12 of 28, and Kentucky, 5 of 6. But not in Florida, and again, surface detection for EHV4 was lower.
Okay, but back to EHV1. There was a specific finding in Florida, wasn't there, about high copy numbers?
Yes, exactly. In Florida, the air samples showed particularly high EHV1 copy numbers. We're talking 3,000 to 8,000 copies per cubic meter of air.
That sounds like a lot.
It is. And crucially, this lined up perfectly with very high EHV1 detection on surface samples from 2 specific stalls nearby. Those had an incredible 1.2 million copies per square centimeter.
Whoa. 1 million copies on a surface swab.
Yes, that's a massive amount. It strongly suggests the presence of what they termed a productive shedder in that specific area.
A horse actively shedding a large amount of virus.
Precisely. And this really challenges that sort of conventional wisdom that it should be a rare event for a horse to reactivate EHV1 from latency and then spread it widely.
So it might be happening more often than we think.
Our data here, collected independently across different continents, really suggests that EHV1 presence, or at least its DNA in shared airspaces, is likely far more common than previously expected.
Huh.
This fundamentally changes how we maybe should perceive and manage biosecurity and herd health at these big gatherings. We might be underestimating the constant background circulation, like invisible embers constantly present in the air.
Invisible wildfire embers. The potent image. So what does this mean for surveillance then, if it's in the air so often?
Well, the study looked at the link between surface and air detection. They found a positive correlation. The statistical measure, Cohen's kappa, was 0.401.
Retreats.
It indicates moderate agreement. So if it's on the surfaces, there's a reasonable chance it's also in the air and vice versa. But the really interesting part for practical use was the predictive relationship. They calculated the positive predictive value, the PPV, for EHV1. It was 90.9%.
90.9%. That sounds really strong. What does PPV mean in this context?
It means that when surfaces tested positive for EHV1, the air in that same environment was also positive in over 90% of those cases.
Wow. So if you find it on a stall door, it's almost certainly in the air too.
That's what this data suggests. It's a powerful indicator. It implies that air sampling can reliably detect airborne viral genome copies when there's surface contamination happening.
Are there any caveats there? Like, could we get false positives or negatives with air sampling that might mislead us?
That's a vital question. While 90.9% is very robust, we have to remember we're detecting the virus's DNA, its genetic material, not necessarily live infectious virus particles.
Okay, the DNA is there, but maybe not viable virus.
Potentially. So while it reliably signals the presence and circulation of viral material, the next step is absolutely validating this against active infectious shedding. But as a tool to flag presence, it seems incredibly dependable based on this.
Got it. And there was another intriguing detail, right, about the amount of virus detected.
Yes. The mean copies of EHV1 detected were actually higher in the air samples across all the study sites compared to the surface contamination, especially when compared to EHV2 and EHV4 levels.
So more EHV1 floating around than sticking to things.
It suggests that yes. It hints that EHV1 might be particularly well suited to aerosolization, meaning it travels efficiently through the air.
That's important for biosecurity. And what about the timing? Day versus night sampling in Spain. Did that make a difference?
Surprisingly, no. Whether the horses were more active during the day shift, 4 p.m. to 10 p.m., or quieter overnight, 10 p.m. to 4 a.m., there was no significant difference found in the airborne viral loads.
So you could potentially sample anytime.
It suggests that sampling timing might not be a critical factor, at least not in these types of naturally ventilated barn settings. That could significantly simplify potential surveillance protocols down the line. No need to worry about hitting a specific peak shedding time window necessarily.
Makes it more practical.
Exactly. Zooming out for a moment, this moderate correlation and that strong predictive value, they suggest air sampling isn't just picking up random bits of virus DNA. It seems to be reflecting active viral shedding happening within that group of horses.
So it could be an early warning system.
Precisely. It implies air sampling could be a really valuable early detection tool. It could signal when you need to go in and do more targeted individual testing to pinpoint those high-volume shedders.
Without constantly swabbing every single horse.
Exactly. Avoiding the labor, the cost, the stress, the potential fomite risk of constant individual testing. However, and this is a crucial next step, we still need to figure out specific thresholds.
Thresholds.
Yeah, like how many viral copies per cubic meter correspond to low shedding versus moderate or high shedding? What level actually poses a significant transmission risk? That needs more work.
Okay. Now, did they notice any other patterns, maybe related to the time of year?
They did observe a potential pattern linked to seasonality. It looked like EHV1 genome detection might be more frequent during the winter event, which was Florida,
Right, December.
and the spring events in Spain compared to the summer event in Kentucky, which was August.
And does that fit with what we generally see with EHV1 outbreaks?
It does, actually. It aligns pretty well with this known yearly recurring pattern of increased EHV1 outbreaks, often with the neurological form EHM happening in the Northern Hemisphere during those colder winter and spring months.
Interesting. Is that just because horses are stabled more, less ventilation?
Well, that's been a common speculation that poor ventilation in winter contributes. But this study's data kind of pushes back on that as the sole explanation.
No, how so?
Remember, these barns had natural ventilation, and they detected other herpes viruses like EHV2 year-round. Plus, EHV4 seemed more common in the summer Kentucky samples.
Okay.
So if it was purely about ventilation being worse in winter, you might expect all the viruses to follow that pattern. The fact that EHV1 had this distinct winter-spring peak while others didn't contradicts ventilation as the only driver.
So there must be other factors involved in EHV1 reactivation.
Exactly. Other, currently unknown or poorly understood factors seem to be driving that seasonal pattern specifically for EHV1.
Fascinating. So what's the take-home message here for event organizers, for horse owners?
Well, it brings us to a really crucial point. While setting up routine air surveillance everywhere right now might not be immediately feasible, equipment costs, logistics,
Sure.
just the knowledge that EHV1 and EHV4 DNA are actively circulating in the air at these events, that fundamentally changes our perspective on biosecurity, doesn't it?
It really does. Highlights an invisible threat.
Absolutely. So the study's authors strongly recommend that event managers and participants really double down on limiting contact, both direct horse-to-horse contact and indirect contact.
Through those fomites again.
Yes, including potential fomite transmission. Be vigilant about shared equipment, hand hygiene, all those standard practices. And this isn't just important at the events, it's critical upon return to home facilities after any commingling.
Bringing something back unknowingly.
That's a huge risk period. And with new tools emerging, like point-of-care tests and generally increased specific testing capacity, they also suggest ramping up targeted testing as a key mitigation strategy. Test more, especially high-risk horses or in specific situations.
Be more proactive with testing. Okay. Now, like any good scientific deep dive, there are always limitations,
Yeah.
right? What were the key ones here?
Yes, absolutely. And it's important to acknowledge them. The main one, as we touched on, is that they detected viral DNA. They didn't perform virus isolation. Meaning, while we know the virus's genetic blueprint was there in the air and on surfaces, we can't definitively confirm the infectivity of that detected DNA. Was it live virus capable of causing infection or just fragments?
We don't know for sure from this study alone.
Correct. That's a crucial distinction.
Any other limitations worth noting?
Well, the surface contamination could reflect buildup over time, maybe over several days.
So it's not necessarily a snapshot of that exact moment like the air sample might be.
Exactly. It makes precise timing, linking a specific shedding event to the amount found on a surface, a bit more complex. The air sample is probably a more immediate indicator of what's currently being released.
Okay.
So, this naturally leads to the obvious question for future research. Connecting that genomic detection, finding the DNA, to actual active shedding of infectious virus. That's the next critical step.
To make it a fully diagnostic, actionable tool.
Precisely. This initial work, which was funded by the FEI, provides a really crucial foundation. It clearly demonstrates that air sampling can be a useful surveillance tool for detecting the presence of viral genome copies.
It proves the concept.
It proves the concept and shows circulation is happening. Further validation is definitely needed to fully grasp the dynamics of this airborne herpes virus burden at horse gatherings and also at home barns, but the evidence for circulation in these shared airspaces, it's now undeniably clear.
So, wrapping this up, what does this all mean for you, the listener? Whether you're learning, you're a horse enthusiast, or just interested in rapid insights into animal health.
Well, I think this deep dive really shows us that sometimes the most important clues come from looking in unexpected places, like the very air we, or in this case, the horses, breathe in shared environments.
Yeah, it's a powerful reminder that pathogens can be much more pervasive, much sneakier than we often assume. They're not always just passed through direct touch.
Absolutely. This study truly underscores that out of sight shouldn't mean out of mind when we're talking about pathogens like EHV1.
So, a final thought for people to ponder.
Consider what this proven airborne transmission means, not just for managing horses at events, but for the everyday biosecurity practices you implement at home. How you manage mixing horses, introducing new ones. What new strategies might you consider implementing, knowing now that the air itself can carry these threats? And how might you act on this newfound knowledge to better protect these magnificent animals, whether they're in your care or attending your events? Food for thought.